Okay, so this is Graphs with Python and Neo4j. This is a two-part series. What I want to accomplish today is outlined right here. You can find this outline with links to respective parts at this URL. That should take you to this agenda right here. So the first part, part one, I first want to do an intro to Neo4j, which if you've been to the other Neo4j presentations might be a bit redundant at this point, but just to be thorough, in case there's someone here who hasn't gone through that yet, I want to cover it. Then some hello world examples using different Python packages and just showing the general API of these packages and how you hook them up to Neo4j, and in general what you'd want to do with those packages with Neo4j. And we'll take a 10-minute break for the part two. The part two will be a bit more, I guess, advanced. We'll go through an example project, and when I talk about project, this is going to be in a data science context. I'm a data scientist, so that's typically how I'm using Python. And then we will attempt to do a workshop, time permitting. We'll get into that when we get there. These links here will take you to a Jupyter notebook that will have all the code that I'll be talking about in the exact order that I'll be talking about it, so you can follow along there in case it's hard to see up here. And that intro to Neo4j up there, that's just a PowerPoint, so there's no link there. So who here knows what Neo4j is? Okay, so this will be helpful then. So for people who don't know what Neo4j is. So, right, I'm Nicole White. I'm a data scientist at Neo4j, and we'll do just a short intro. So a little bit about me first. I currently work for Neo4j as a data scientist, and I actually went to grad school here in statistics, so it's good to be back. And I went to undergraduate at LSU. Yeah, sure. Actually, I have a bit more loyalty to LSU. I think I spent more time there, so I'm more of a Tiger fan than I am a Longhorn fan. But hopefully we can still get along.
Yeah.
They're not really rivals, right? I mean, I'm not a football person, but different divisions, I'm pretty sure. So anyway, I got a degree in math and economics at LSU. So I spent 4 years down in Baton Rouge. Then I spent roughly 2 years here at UT Austin getting my degree, and I think it's technically called an analytics degree. It's a joint effort between the statistics department and the computer science department. This is my first real world job out of school here at Neo4j. So this is, I guess, our mini agenda for this little intro that we're doing. First, what is a graph? And then we'll talk about what is Neo4j. Then we'll do some data modeling, a little exercise where we'll translate a SQL model into a Neo4j model. I think that's usually the easiest way to introduce Neo4j, is to take something you know, which is usually SQL, and translate it into a graph model. And then we'll look at Cypher, which is Neo4j's query language. That'll be a necessary step because we'll be writing a lot of Cypher queries to grab data out of Neo4j into Python. So I think it's quite necessary to understand, at least have a decent understanding of Cypher before we move on. So what is a graph? Pop quiz number 1 of this presentation are these graphs. I need everyone to participate. Either raise your hand if you think these are graphs. Okay, this guy thinks these are graphs. Who thinks these are not graphs? Okay, yeah, right. These are what we call charts. This is a bar chart and a line chart. And when we're talking about graphs at Neo4j, this is what we're talking about. We're talking about a collection of nodes that are potentially connected by relationships, right? So that when I say graph, you should think of this and not a bar chart. So what is Neo4j? Yeah, it's okay. Everyone makes that mistake. What is Neo4j? So Neo4j is a graph database. And graph databases are in the NoSQL category. And depending on who you ask, that's either not SQL or not only SQL. Either way, it just means it's not a relational database. It's not a layer on top of a relational database. It's a native graph database. Right, so it's a NoSQL category database. And we were founded in Sweden. So here we have a graph with nodes and relationships. But potentially I might want to say a bit more about these nodes and relationships to clarify a few things. So I might put a property on these nodes. So maybe a language property on the Sweden node saying the language is Swedish, a key value pair here. I might put a property on the Neo4j node saying that open source is true, because Neo4j is open source. And I might put a property on the relationship itself saying, I don't think that year is correct, this is just an example, saying that Neo4j was founded in Sweden in the year 2007. And this is what we call the property graph, and that's in essence Neo4j, and Neo4j allows you to store your data as a property graph and to query it as a property graph. And I'm showing all the different combinations for the most part of what you can store on your nodes or relationships as these key value pairs. You can store Boolean true false, numerics, or strings. And let's do a quick data modeling exercise. Oh, and by the way, I want to mention that if those time slots that I had outlined, those allow for questions, during the talk. So feel free to interrupt me as they come to you, because I think we have plenty of time to answer questions as you think of them. So data modeling. Like I said, I think the best way to explain Neo4j is to take what you know, which is SQL. Who here has used SQL, a relational database, and has written maybe at least one SQL query? Okay. Okay, great. So take you on a journey from tables and foreign keys to nodes and relationships. So let's take a hypothetical data set. Let's say we have YouTube-style data where we have users and channels. So we have our users table, of course, with some primary key and then a field with their username and probably a bunch of other stuff about that user. We'd have a channels table with a primary key of some sort and then the name of that channel, probably some other fields in a more realistic example. And then let's say we also wanted to model the idea of a user having created a channel or owning a channel, as you can do on YouTube. In that case, we'd have to create a separate table. Usually the convention usually is to call it like users channels, the names of the two separate tables that will eventually have foreign keys to the two primary keys. So if we wanted to model a user owning a channel, we'd create this table in the middle, which at the least it has these two keys that have foreign keys back to the primary keys of the respective tables, right? So here we're saying user 2 owns channel 1, and then you go look at the users table, it's like, okay, user 2 is Bob, and he owns channel 1, which is Bob's game channel, right? So that's a very classic way that you would represent this kind of data in a relational database. And then if we wanted to answer a question that involved a user operating a channel and you wanted to also get the names of those things, we'd have to join across all three of these tables, right? Additionally, we also want to model users subscribing to other users' channels. So that's another table in between all of this, right? So here we're saying user 1 subscribes to channel 3. So user 1, you have to go look it up, is Alice. Channel 3 is Cooking with Charles. That's channel 3 in the channels table. And then if you also want to see who owns that channel, you have to go look at this user's channels table. Which brings me to the next point, which is, of course, if you want to answer questions that involves all of this data, you have to join across all 4 of these tables, right? And even in this very contrived, simple example, we got a pretty complicated query hanging over our heads already. And not unrelated to the way you visualize your data more or less when you're modeling these tables. I don't know if you guys have used like Visio to create those, what are they called? When you create those SQL diagrams. I forget, because I've done it.
Entity relationship.
Entity relationship? Yeah. Something like that. Yeah, it's been a while since I've done that, so I forgot. But I remember making these diagrams in Visio, saying, okay, this is a foreign key over here. And so it's hard to say, like just looking at this, who subscribes to channels owned by David, right? We'd have to do a lot of visual scanning of the numbers and whatnot. And so not unrelatedly, it's also, I think, difficult to answer that question in SQL, or it's more difficult than it should be, right? I mean, this isn't the worst thing in the world. But if you want to answer the question, who subscribes to channels operated by David, we've had to incorporate information from all 4 of those tables, and so we had to join across all of them, and I feel like that's way too many lines of SQL to answer such a simple question, right? So, let's switch gears here and look at how we would model this same data in a graph, or Neo4j in particular, a property graph. So, Neo4j has a concept of node labels, so there are different node types. So instead of having, we have our users table in relational, we now have a user node in Neo4j. It has a user label on it. I'm going to have blue nodes for these user nodes. And we'd have also a different type of node for the channels with a channel label. And those are going to be green in this case. So we have 2 different types of nodes in this database. And so they have 2 different node labels, user and channel. And then we also want to put some properties on these nodes to identify which node is which, of course. So instead of having a user's channel with our name field, we have a user node with a name property, which is a key value pair. So here are the name of this user in particular is David, this user is Alice, so it's just a key value pair there on the nodes. And then of course our channels also have names too. So the channel nodes are also going to get this name property, again just a key value pair, saying what the name of the node is. And now to model, again, we want to model users operating channels or having created a channel. You would create a relationship type between those nodes, and you would give that relationship a name. So here I decided to use the word operates. So for all the users who operate channels, there's a directed operates relationship from the source node, I suppose, the user node, pointing to the target node, the channel node that user operates. Then we also wanted to model users subscribing to other users' channels. So in that case, we would just create a different relationship type in the graph. Here I've called it subscribes, saying this user subscribes to this channel, right? And so this is how you model your data in Neo4j as a property graph, where you have node labels, relationship types, and then properties on both nodes and relationships. And so visually, it's much easier to answer questions like, who subscribes to channels operated by David? You can very easily see, okay, David operates these 2 channels over here, and I can see that these 2 users subscribe to those channels. And not unrelatedly, it's also, I think, very easy, or it's easier to express these types of queries with Neo4j's graph query language, Cypher. So this is answering the same exact question with the same exact data, except we're using Neo4j's Cypher query language to get that information out of our graph. So I'll go into Cypher into a bit more detail about Cypher in a bit, but I guess I'll start now. You essentially draw out the graph pattern that you're interested in matching on. So here we're drawing nodes with open and closed parentheses, like a little circle. Then we're drawing relationships with open and closed square brackets. And usually when you see a colon in this match clause, it means I want something of this type. So here we're saying we want this node to have the user label. We want this relationship to have the subscribed type. We want this node to have the channel label, and so on and so forth. So colon, whatever, means I want something of this type to be in this spot. So that's the match clause. And then our where clause works very similarly to a SQL where clause, where I say I want this property to be this value. So here we call these, I think we've decided to call these variables now. U and D are variables. I've bound those nodes to those variables. And here I'm saying that the name property on that node that's been bound to that D variable, which is that user node over there, I want that to be David because we asked who subscribed to channels operated by David. So I want the user that has the operates relationship pointing to the channel. I want that to be the David node. And now we're returning the named property off of those user nodes who are subscribing. So that is Cypher in a nutshell. Cypher is very, we're only going to get our feet wet with Cypher. There's much more to learn. But I think it'll be enough to get us through the Python stuff that we'll end up doing. If you want to sit through 8 hours of Cypher, I'll be doing a training on Tuesday, if you want to come to that. But unfortunately, we don't have time for that. So let's look at a few more Cypher queries in what is called the Neo4j browser. So this, we're just going to look at a few more, and this would be what you'd be working with if you were to install Neo4j. Neo4j ships with the Neo4j browser. It's just a query workbench, if you will, to write Cypher queries and get results back visually or as a table, whichever one you're querying for. So this is the same exact data that we had in the PowerPoint, except now it's actually in a Neo4j database and not on a slide. And so here we have our user nodes. So the Neo4j browser is going to show you this like legend of this is the node label. So we have these two node labels, the users and channels. And then if you click on a node, it'll show you all the properties there at the bottom, all the potential properties on that node, the key value pairs. And so here's our same graph. Lots of stuff going on with the browser. I won't cover it though. I just wanted to show a few more queries just so we're all a bit more familiar with it before we go into the Python side. So if you wanted to get channels that Alice subscribes to, that's an easier query than the one we just looked at, where we're just matching on a simple node relationship node pattern here. So we're matching on user subscribes to channel, where the name of that user is Alice, and then we're returning the name of that channel. And in the Neo4j browser, when you ask for a property in the return clause, so here we ask for a property, it's going to give you a table instead of the actual nodes and relationships. Yeah. Can you enlarge that a little bit? Yeah. Is that good? Yeah. Right. So like in this display down here, I returned the actual nodes themselves. I returned the variable alone, and so it gave me an actual visual representation. Whereas here, I'm asking for a specific property, and so in that case, it just gave me the table. And this is the same query we just looked at, so I won't go through it. Just to prove that it does work, though. You could never trust code from slides, so this is the same query that we just did in the slide. This is kind of hard to read with the reduced real estate. I'll increase it again, but here we want to find mutual subscription. So this is an example of something that would be reasonably annoying to write in SQL that is pretty straightforward, I think. In Cypher, we want to find people who mutually subscribe to each other's channels. So I'm subscribed to a channel that you operate, and you're subscribed to a channel that I operate, right? I guess we're trying to find a circle here. So here, we can express that entire pattern in a single match clause saying, I want a user that subscribes to a channel where some other user operates that channel, and then that same user, you too, subscribes to a channel that I operate. So it's very easy to express these kinds of patterns in just a few lines of Cypher. And so here we can find that Charles subscribes to a channel operated by Bob, and Bob subscribes to a channel operated by you. Or Charles, sorry. And Cypher also has, like a bunch of, like all the classic query things, language things you would expect, like count and average and sum and min and max, all the things that SQL can do on that front. So for example, we might want to find channels with 2 or more subscribers. And this is probably more like SQL's having, like finding stuff that having this is true. So here we want to find, we want to match on the channels, and then with those channels we want to count how many users have a subscribed relationship to that channel, which we can use the size keyword to do, where that is greater than or equal to 2, and then return the name of that channel and subscriptions. So just another example. I forgot to increase the size after I did that. Another example of how you can use Cypher for just basic counting kind of stuff. And then a very powerful part of Cypher is the ability to find shortest paths within Cypher itself, which is quite nice. It's just been built into the language. So here, let's say you want to find all the shortest paths between Charles and David. This is very powerful because a lot of times these paths, you don't know if they're 2 steps or 4 steps or 5 steps. These kinds of path-finding queries are not impossible in SQL, but you usually want to know up front how many steps you need to go, because you usually have to join a table on itself over and over until you have found the end. There's fancy things you can do in SQL, but it's not straightforward, whereas in Cypher I would say it's very straightforward. So there's an all shortest paths function. We're going to pass the start node and end node, saying where the names have to be Charles and David, and then we're saying it can traverse relationships of any type, and the path can be any length, and then we should get a path back here. So there are a couple shortest paths between Charles and David. One of them going through Alice, and then another one of them going through Bob. So that is a short and sweet introduction to Cypher. Hopefully it's enough to get the ball rolling.